Hello everyone, welcome back to the series of DSA for placement. If you are targeting the product-based company, then this series will definitely help you. Because in this series, in every session, I'm taking the problem from product-based company, from man companies, and we are solving this problem in every session. So definitely this series will help you if you are targeting the product-based company. If you are an advanced learner, you are welcome over here in this series. I'm covering product-based company problem in every session. And the second thing, if you are a beginner, still you are welcome to this series because I'm covering the basic concepts also with the help of a quiz. Okay, with the help of a quiz. So definitely this will help you. This series will help you if you are an advanced learner as well as if you are a beginner. Both type of people can enjoy this series. Let me share my screen and let me show you the complete roadmap of this series. Please confirm me if I'm properly audible or not before moving on. Please confirm me if I'm properly audible or not. Kindly confirm. So this is let me tell you meanwhile, this is the sixth lecture in this series and we are covering bitwise operators today. We will solve two product-based company problem from this topic, bitwise operator. Okay, two problem we will solve. One thing, this is what we will do today. Second thing, we will take a quiz. The quiz will cover the basics of bitwise operators. So if you want to cover the basic questions related to bitwise operator, then that quiz will help you, and that quiz will ensure you that if you are scoring good in that quiz, you have basic knowledge to appear for product based company. Your base is ready in this topic, bitwise operators. Your base is ready. Okay, so you can ensure this thing by going through that quiz. And if you are doing good in that quiz, you will also get a cash reward. Okay, so these sessions are having knowledge also itself, because we are covering the product based company problems and we are covering the basics also with the help of the quiz. Not only knowledge, but this series is also a fun series because we are taking the interesting problems just like games. We are learning through games, first thing. Second thing, we are taking the quizzes in this series. The quiz, if you're doing good in the quiz, then you are getting the cash reward also. So here we are learning also, and you people can earn also. So before moving on, please confirm me anybody I'm properly audible or not. Please confirm in the chat box if I'm properly audible or not, so that we can move on. Meanwhile, let me show you what we have covered till now. Till now, we in this series we have covered the five topics. These five topics like motivation to study DSA, time space complexity analysis, time complexity analysis of recursive code, asymptotic notations, arrays. Till here we have covered. Today we are covering this topic. So again, I'm repeating what I'm going to do. First thing, two mang problem. Mang problem we will cover today. First thing is this. Second thing, there will be a quiz. There will be a quiz. Quiz will be covering the most important topic, most important questions, most important questions we will be covering from. The question will be from bitwise operators. Okay, so through this quiz you can ensure yourself that you are good at this topic. Okay, if you are doing good in the quiz, you can ensure yourself, yes, you have the base, you have good base on this topic. Okay, and if you're doing if you will get the highest score in the quiz, then you will also get the cash reward. Fine, so these are the two things we are doing in every session. We are covering the mang problem and we are taking a quiz also. So today also we will do the same thing. Thanks Talk for confirming. Thanks Ishi for confirming. So let's start with the bitwise operators today. Let's solve a problem related to bitwise operators. You people please reply, try to answer this question. Okay, this question is from the Qualcomm. Okay, and what is the question? Question is like this. We need to find out the power of, we need to find out, okay, if the given number is in the power of 2 or not. If is the given number is in the power of 2 or not. For example, 2 power 1 is in the power of 2, or you can say okay 2 power 2 is also in the power of 2, or you can say that okay this is equal to 4. So what about okay 8 is also power of 2. And if we talk about 16 is also power of 2, that is 2 power 4. So we need to tell that okay given number is in the power of 2 or not, is the power of 2 or not. Okay, this is what we need to find out. Today we need to find out. So they provide us given a number n, and we need to return true if it is in the power of 2, if that number is in the power of 2. So can you reply? Okay, let's see if you understand the problem statement or not. Can you tell me if n is 1, this is in power of 2 or not? N is equal to 1, this is in power of 2 or not? Yes or no? Yes or no? True or false? Please reply. This is true or false? Anybody reply? This is true or false? If n value is 1, so that is in the power of 2 or not? Yes or no? Anybody if can reply? So let's see if you understand. Okay, 16 is in the power of 2. 2 power 4 is 16. Yes. So this for this input we need to return true. What about this one? N equal to 3. For n equal to 3, n equal to 3 is not in the power of 2. Okay, so 3 is not comes in the power of 2. So for this we need to return false. Yes, Ranker Stock, you are right. This is true, this is false, and this is also true. Yes, you are right. This is true because you know that 2 power 0 is how much? That is 1. So yes, 1 is comes in the power of 2. When you are putting in the power 0, then you will get 1. Yes, you are right. Yes, you are right. So for example, 1, if n value is 1, this is in power of 2, yes. If we are making power of 2 as a 0, then we will get 1. 16, yes, this is also in power of 2. 3 is not in the power of 2. 3 is not in the power of 2. So we will return false for this. We will return false for this. Okay. So how we will solve this problem? How you will solve this problem? Any idea coming to your mind, please share. Any idea coming to your mind how you will find out? Somebody provide you a number, okay, and ask you, is this number is in the power of 2 or not? How you will find out this thing? One easy solution can be okay, one easy solution can be like you can uh, you can start with the 1, okay, like this, I value 1, while I do not reach to the n, you can multiply I with 2. We can multiply every time I with 2. So this is what we can do. We keep doing this thing until unless I is not reaching to the n. Okay. So I starting from 1. For example, if let's suppose n is 16. So let's see if what this will return. This code will return. So if I equal to 1, then I will be equal to 1 into 2. So in first iteration I will be 2, and in second iteration I will be 2 into 2, that will be 4, and the third iteration that will be 4 into 2, and in the next iteration that will be 8 into 2, 16. So when I will be 16 and this is not less than 16 and value is also 16, we will come out of this loop. So after coming out of this loop we can simply return, if I is equal to n, then we will return true, otherwise we will return false. Okay. So this is one idea, means how we can solve this problem. Simply somebody, the question is like this, somebody give a number and he is asking, is this number is in the power of 2 or not? Is this number is in the power of 2 or not? So simply we will keep multiplying until unless we do not reach to that number. If we reach to that number exactly same to that number, then yes, that is in the power of 2. Otherwise that we can say that that is not in the power of 2. For example, if let's suppose in place of 16 we have 15 over here, so in this case we will come out of this loop when I value will be 16, and when we come out of this loop I value will be 16, which is not equal to 15, so we will return false. We will return false. Simple. One simple idea can be this. One simple idea can be how we can find out if a number is in the power of 2 or not. We can keep multiplying the number. We can keep multiplying with 2 every time, and until unless we do not reach to that number, until unless we do not reach to the end, we will keep doing this thing inside a loop. And after coming out of the loop we can check out, okay, if the number last number which we get is equal to n or not. If that is equal to n, then means number is in the power of 2. That number is in the power of 2, otherwise not. That's it. Otherwise not. So this can be simple idea to solve this problem. Okay, let me try to implement this idea into the okay coding screen. I'm going on. So here is the problem. So I have taken this problem from the lead code. Let me copy it and share with you people. So this is the same problem. So here you can see that, okay, this is the same problem, power of 2. We need to find out, okay, they provide us a number n. We need to find out, okay, is this number is in the power of 2 or not? This number is in the power of 2 or not? So what is the idea? Simple. If n is equal to 0, if the provided number is 0, that is not in the power of 2. Okay, if n is 0, then return false. Return false. Okay, otherwise we can take a number. Okay, let me take a number I equal to 1, and I will keep multiplying it with 2 until unless while we do not reach, while our I is less than n. Okay, we will keep multiplying I equal to I into 2, I into 2. Just a minute. I into 2 into 2. So we are just multiplying every time I with 2 2 2 until unless we do not reach to the n. And after coming out of this loop, if I is exactly reach to n, that means n is in the power of 2. So return true if I is equal to n. Okay, so simple. If I equal to n, after coming out of this loop, means n is in the power of 2. Otherwise this will return false. This will return false. So that's it. We can submit this code, and it's working fine. This is the one way we can solve this problem. Okay, this is the one way we can solve this problem. Can anybody tell me, okay, what is the time complexity of this code? What is the time complexity? How much time this code will take? Let's see if anybody can reply or not. Ranked stock, anyone, if can reply or not. How much time this code will take to execute? How much time this will take? This code will take to execute. How much time this will take? So, okay, let me tell it from my side. This will take log n time. This will take log n time. Okay. Yes, you are right, Ranked stock. This will take log n time. And the reason here is that this loop, whenever simply you can take a thumb rule for the low complexity, people find difficult to find out, okay, if to find out that, okay, complexity is log n or not. To finding that log n complexity, people find difficult. You can take a thumb rule that, okay, whenever you are multiplying a number with 2, or you are dividing a number with 2, whenever you're multiplying or divide a number with 2, the complexity will be log n only. Okay, you just take this thumb rule. That will always work. That will always work. So here I value is starting from 1, and we are going up to n, and every time we are multiplying with 2. Whenever every time you will multiply with 2 or divide with 2, the complexity will be log n. Okay, the complexity will be log n. So this code will take log n time to solve this problem. Okay, Simply we find out, okay, given number is in the power of 2 or not. But the idea we use, the idea is simple, is that, okay, we just keep multiplying the number with 2. We start with 1 and keep multiplying with 2 until unless we do not reach to the, we keep multiplying it with 2 until that is less than n. Until unless this number is less than n. So at the end, what can happen? This whatever number we are getting here, that can be equal to n. If that is equal to n, so n is in the power of 2. Yes. If after multiplying every time with 2, we reach up to exactly n, then the n is in the power of 2. Otherwise, that is not. That's it. This can be one idea. This can be one idea. But we can solve this problem in constant time also. We can solve this problem in constant time also. In constant time also we can solve this problem. How we can solve this problem in constant time? How we can solve this problem in constant time? Any idea, anybody? How we can solve this problem in constant time? So one way we applied, okay, we just solve this problem using the, just using a loop, keep multiplying the I value with 2 until unless we do not reach to n. So we solve this problem using a loop itself. This is taking log n time. We can solve this problem by using bitwise operator also in constant time. How? So this is the one idea I'm telling you, okay, we can note down. So what can be another way to solve this problem is, how we can solve this problem? See, if there is a number which is in the power of 2, so what can be the number in the power of 2? So for example, 2 power 0, or 2 power 1, or 2 power 2, 2 power 3. These are the numbers in the power of 2, okay. And if we represent them in binary, okay, this is 2 power 0 is 1, 2 power 2 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. So if you represent these numbers in binary, then you will notice one pattern. You will notice one pattern. So this is, I'm writing 1 in binary. Maybe, okay, 0 0 0 1. So this is in 1 in binary. How we write 2 in binary? 0 0 1 0. How we write 4 in binary? 0 1 0 0. How we write 8 in binary? 1 0 0 0. How we write 16 in binary? 1 0 0 0 0. So this is we write, how write 16. 2 power 5 is 32. How we write 32? 1 1 2 3 4 5 0. So this is how we write 32. So one pattern you will notice that, okay, if a number is in the power of 2, if a number is in the power of 2, then if we if you will see the binary equivalent of that number, then in binary equivalent only one bit will be set to 1, okay. MSB, you can say that, okay, most significant bit will be set to 1 and all other bits will be 0. So you can see over here also, this is also only one bit is set to 1. If the number is in the power of 2, which is we need to find out if a number is in the power of 2 or not. And in binary we are looking one pattern, okay. In binary, if we are converting this number into binary, you will notice that the MSB bit will be set to 1. The MSB bit will be set to 1 every time. Here also one bit will be 1, all other bit will be 0, one bit will be 1, only one bit will be 1, okay, if a number is in the power of 2. So is this, can we take the benefit of this information? Yes, we can take the benefit of this information to solve this problem. How we can solve this problem using this information? See, let's suppose I need to find out if a number is 16 or not. So one thing I know, that if a number is in the power of 2, then if we are converting it into binary, then only one bit will be 1. MSB bit will be 1, all other bit will be 0. So if I'm writing 16 over here, 1 0 0 0 0. So this is 16. And if I perform AND operation, This is 16 and I'm writing 15 over here. 16 minus 1 is 15. So this is how we write 15 in binary. All this bit will be 0, all other bit will be 1. Okay, so this is 16 in binary, this is 15 in binary. And if you will perform the AND operation, then you can see that 0 1 0 0 1 0 0 1 0 0 1 0 0 1 0. So we will get 0 only. What I want to tell you is that if a number is in the power of 2, then only one bit will be set to 1. Okay, and if I'm subtracting, if that number is, let's suppose, 16, and I'm making AND operation with 15 with it, in 15 actually, except this MSB bit, all bits will be 1, all bits will be 1. And if you are performing AND between these two, then you will get 0, you will get 0 output. So we can take the benefit of this idea. What we can do to find out, okay, if a number is in the power of 2, one thing we have noticed that in binary, one MSB bit will be set to 1. For every number which is in the power of 2, only one bit, MSB bit, will be set to 1, all other bit will be 0. Okay, and if I am making AND to this number with one minus number, okay, then we will get the 0 value. So if we are getting the 0 value, means the number, this number was the even number, this number was the in the power of 2, this number was in the power of 2. Okay, I'm taking another example to clarify this point again. So what I'm saying simple is that if a number is in the power of 2, then MSB bit in binary will be 1. Okay, all other bit will be 0. Okay, this is confirmed. You can check out for any number. So if, let's suppose, we have 32. So this is 32. 1 0 0 0 0 0. This is 32 in binary. Okay. And how we write 31? This is 32. How we write 31? In 31, all these bits will be 1 and this bit will be 0. Okay. This is 31 in binary. And if we are performing AND operation between them, then we will get 0 actually, because definitely these two bits are different bits. This is 0, this is 1, this is 0 1 0 1 0 1 0 1. So everywhere we will get 0 actually. So simply I can solve this problem by performing AND operation between the given number. So let's suppose n is the given number. If I'm performing AND operation with this number with n minus 1, okay, and if I'm getting 0, if I'm getting 0 means the number was this number was the in the power of 2. This number was in the power of 2. That's it. So by just performing AND operation with the given number with the n minus 1, like given number is 16, perform the AND operation with 15. If we are getting 0, then we can say that, okay, the number was in the power of 2. Otherwise, the number was not in the power of 2. That's it. So this is the one idea we can follow, and we can solve this problem in constant time. We can find out this thing in constant time that, okay, if a number is in the power of 2 or not. Fine. Okay, let's do it. Let's do it in the coding. So just, okay, I'm replacing this much code. So when n value is 0, we can return false. If n value is 0, that is 0 is not in the power of 2. Okay, so we are returning false. Otherwise, what we can do, simply we can return true, return. So okay, we have stored this n value into I, or maybe, okay, I'm taking variable x over here, x, taking this x, performing AND with x minus 1. And if I'm getting 0, then we will return true. If this condition will be true, then this will return true, otherwise this will return false. Okay, so if this condition is true, then x, or you can say n is the number which is in power of 2. Okay, that's it. So we can submit this code, and you can see that, okay, our code is accepted over here. So we solve this problem now in how much time? The same problem which earlier we solve in log n time. This time we solve this problem in order of one time, constant time, by using the bitwise operator. So for this thing, we need to just check out that, okay, if we are writing a number in binary, and if the number is in the power of 2, then this thing must be known to you that, okay, the m all, if the number is in the power of 2, then only one bit will be set to 1. Okay, this is the thing you must be knowing. Okay, this must be known to solve this problem. And this is the very basic thing. Means in binary we know that, okay, uh, if we are writing 1 2 4 8, 16, 32, 64, 128, 512, 1024, any number which is in the power of 2, if we are writing any number which is in the power of 2, then only one bit will be set to 1. Okay, all other bit will be 0 in that. This is how we write in binary, and we take the benefit of that. We just perform AND operation of that number with one smaller number, and one smaller, in one smaller number, all bits will be 1 except the MSB. And if we are performing AND between them, then we will get 0. And if we are really getting 0, means that number was in the power of, that was in the power of 2. That's it. So this is how we can solve this problem in constant time. In constant time. So I'm going to this screen back. Any doubt in this, you can ask me any doubt if coming to your mind. Otherwise, let's solve one more problem related to this itself. So there is another problem, okay, I'm sharing with you. That is the power of 4. Power of 4. So they provide us a number n, and we need to tell, is this the power of 4 or not? So, okay, for example, I'm going to my PPT back. If we are going to PPT back, okay, if 16 is in the power of 4 or not? Yes, 4 square is actually 16. Yes, this is true. We will return for this. N equal to 5 is in the power of 4 or not? No, this is not in the power of 4. N is not, 5 is not in the power of 4. What about 1? Yes, 4 power 0 is 1. So yes, for this n value 1, we will return true. Okay, so this is just similar to the previous question only. In the previous question, we were finding, okay, if a number is in the power of 2 or not. And here we are finding if a number is in the power of 4 or not. Okay, so any idea how you will solve this problem? Somebody provide us a number, and how you will find out that, okay, that is in the power of 4 or not. Similar type of question which is asked in Adobe and many other companies also, this same question. Actually, this is also the we can solve this same problem using bitwise operator again, and by using some mathematical calculation actually. Okay, let me show you. Okay, yes, we can simply divide by 4 itself. Ranker stock, we can divide it by 4 itself. Okay, let me go to this problem, and let me use the idea shared by you. Let me use the idea shared by you. You are saying that take a number every time, either divide it by 2 or either multiply it by 2. Okay, I'm just using the previous idea only. So if n is equal to 0, then we will return false. So this is the base condition. False, we are returning false. Okay, and I'm taking a number long I equal to 1. Just similar way I'm solving this problem also. While I is less than n, this is, yes, you are right, this is the one way we can solve this problem. I equal to I into 4. Keep multiplying the I value by 4 until unless we reach to n. And if we reach to exactly n, then we will return true. So if we reach to exactly n, then we will return true. Otherwise, we will return false. That's it. Yes. we can solve this problem like this way also. So let me submit this code. So I think you are talking about this thing. Yes, this solution is working fine. This way also, the same way we can solve this problem. But here also again, how much time this will take? This will take how much time? Log n time. Log n base 4. Okay, log n base 4, this will take time. Because every time you are multiplying with 4, every time I is multiplying with 4, 4, 4, 4, so the complexity will be log n only, but you are multiplying with 4, so the log n base 4 will be the time complexity to solve this problem. Okay, but we can solve this problem also in constant time by using bitwise operator. Okay, how we can solve? Okay, so this is the idea I'm sharing with you, how we can solve this problem in constant time. So you already give me the solution in log n time, log n base 4, that is working fine. Yes, but we can solve this problem in constant time also. What you need to know? So see, if a number is in the power of 4, then the same number will be also in the power of 2 also. One thing is sure. If this is in power of 4, then this will also be in the power of 2. Okay, this will also be in the power of 2. So like 16 is also in the power of 2, and 1 is also in the power of 2. Okay. What about but vice versa is not true. Like 8 is in the power of 2, but 8 is not in the power of 4. Okay, 8 is not in the power of 4. 8 is in the power of 2, but 8 is in the, but one thing is confirmed. If a number is in the power of 4, then that number will also be in the power of 2. Okay, one thing is sure. At least we can reduce some our problem space by finding, okay, if a number is in the power of 2 or not. First thing we can check, okay, if this number is in the power of 2 or not. Okay, and after that, if you will do some calculation, then you will find out, okay, let me see what are the number of in the power of 2. So 4 power 0 is in the power of 2, 4 power 1 is in the power of 2, 4 power 2 is in the power of 2. Okay, she is asking, okay, how we choose which logic is better. So see, you can start with this solution itself, which is coming to your mind. You are giving me the logic of this logan. Yes, this is working fine, this is working fine. Okay, after that okay, we are trying to solve this problem in less time. Order of 1 is less. Okay, order of 1 is less than log n. Okay, this is less than log n. So if you can solve this problem in order of 1 time, then that is better than log n. In this case, you were executing through a loop, but here you just executed one statement and you solve this same problem. So let's see if we can solve this same problem in constant time or not. What you need to observe, first thing you observe is that this number, the number which is in the power of 4, that will also be in the power of 2 also. Okay, one thing is this you can observe. Second thing, you can observe a pattern over here. 4 power 0, 4 power 1, 4 power 2, 4 power 3. For every number, like 1 here, 4 here, 16 here, and 64 here. If you will take the, okay, see, if you will take this number mod with 3, then you will get the remainder 1. Every time you will get the remainder 1. Every time if you will take the mod of any number which is in the power of 4, you take any number which is in the power of 4, if you will take the mod with 3, then you will get the remainder 1. Okay, so by using this mathematical finding, you can use this mathematical finding, okay, uh, to solve this problem. Okay, you can solve this in log n time, that is also fine. But by using this mathematical finding, that okay, if we are taking input number and taking mode with 3, and if you're getting remainder 1, then you can say that okay, that is in the power of 4. Okay, so you can combine these two things. Means if a number is in the power of 2 as well as, and if its remainder is 1, by taking mode with 3, then the number will be in the power of 4. Okay, so by using these two findings, we can find out, okay, number is in the power of 4 or not. Okay, let me apply it over here. Let me apply this same thing over here. So I'm deleting this part, storing, okay, I'm taking x is equal to n, and simply see, earlier what we were doing in the power of 2, we were just taking x and x minus 1. This is how we find out that, okay, if a number is in the power of 2 or not, okay, by writing this statement. If we are getting 0, if you are making and between x and x minus 1, and if we are getting 0 means the number is in the power of 2. So the number should be in the power of 2, and the number should also be, if we are taking the mode with 3, then that should return 1. That should this is the another mathematical finding. Okay, you can verify this thing. If this is also happening, if both condition are true, then we can say that, okay, the number input number is in the power of 4. Okay, simply just checking these two finding, we can predict that, okay, number is in the power of 4 or not. Okay, so let me submit this code. So yes, this is working fine. Simply just here what we are doing, we are checking two things. One is the number should be in the power of 2. If the number is in the power of 4, then that number will also be in the power of 2. This is the, we use the concept from previous question. And here one more finding, if you will verify for taking examples, if you will verify that, okay, if you are taking mode with 3, then the remainder will be 1. If you are taking if you have a number which is in the power of 4 and you are taking the remainder, if you are taking the mode with 3, then you will get the remainder 1 in that case. Okay, you can check out that thing also, and if both conditions are satisfying, then we can say that the number is in the power of 4. So this can be another way, okay, to find out if the number is in the power of 4 or not. Okay, so this will also take constant time, and this is the solution in Java, the same solution in Java, and this is the solution in Python. So this is the solution in Python. Fine, okay. Any doubt in this? You people can ask me anything, we can discuss over here. So we just solved two problems, somehow related to each other, and ask in so many companies you can see over here: Apple, Adobe, Amazon, Negero, Two Sigma, Wix. So the idea is interdependent on each other. These two problems are related to each other. Okay, so we solve this problem in constant time. First we in log n time, then in constant time. Fine, okay. Any doubt you we can discuss over here. Otherwise, let's move to the second part of this session. That is the quiz part. And if you will score good in the quiz, then you will get the cash reward. Okay, you will get the cash reward if you will be doing good in the quiz. And the important part in the quiz is that we will be covering the important questions from bitwise operators. Okay, I have added the important questions, basic question, but important question from bitwise operators. So try to attempt that, and then we will discuss those questions also. These are the basic bitwise operator questions which I have added into the quiz. So you can try to give the try to find out this. Okay, I'm sharing the quiz with you people now. Math, Ranker Stock is asking, okay, do we need math to learn the DSA? For DSA, you need the basic mathematics. Okay, for DSA, you need the basic mathematics. You do not need to be like, you do not need require the math of 11th and 12th standard. Up till 10th level, math is more than sufficient, and the basics of the maths is required, uh, like finding the log and finding a square root and all that basic things are required for DSA. Not very advanced level mathematics is required. Fine, okay. I'm sharing the quiz with you people. So just a minute, let me share the quiz. So I'm starting the quiz. So the quiz again, I'm repeating. This quiz have the basic question but important question from bit manipulation. Try to give, try to attempt these questions. This will ensure you that your base is ready in DSA or not. Okay, you can ensure this thing through this quiz. I'm sharing it with you people now. Let me share the link for this quiz. So if you will be the winner in this quiz, you will get the cash reward also. So join this quiz. Let me share the code also. The questions are important in this quiz, although those are basic but important from bit manipulation. If you can answer these questions, means your base is ready in this topic, particular topic, bit manipulation. And to make it fun, you can enjoy also. Important part is that the questions are in basics and important questions are there from bit manipulation. So you will learn that part also with the help of quiz. And after completion of quiz, I will go through all these questions. And if you have not filled this form, then fill the form also. I'm sharing a form link so that I can transfer you your reward. Okay. So if you have not filled the form, you can fill this form also. Okay. So try to attempt these questions. You will find it important. These questions will again help you to revise the concepts and will make you sure that okay your base, at least base, is ready in bit manipulation. So let me start the quiz now. Try to attempt, then we will discuss these questions. Try to attempt. Let's see who is here. Sri is here, Venkatesh is here, Karthik is here, Ishi is here, and Raghu is here. Keep trying. Again, Karthik is doing after that Rahul, after that Rishi, after that I will stop. After that, Karthik is too many. He had actually and Rahul and Vikas talk. Rishi, and also if we keep trying, why are you stopping? Keep trying. So please let me know if the thing is finished. So please now state my please the new one. So please let me know if you finish the quiz. Please let me know if you've done it. this time we have Karthik Rahul also. He's completing an interest of also 5,550 points. Almost Karthik and Rahul are at the same point. Now you can beat Karthik. So, okay, now ending the quiz. I think you people have done. I think. I'm ending the quiz. So Karthik again the topper this time again, but this time we have Rahu also, who is the second position. Uh, Congratulations, Karthik and Rahul and Ranker Stock also you have done good today, and Ishi and Utsavi, great. Keep participating, keep learning. Okay, so today. Rahul, you are the, I think you first time participated and you scored very nice score actually. So will you please share your contact number? Have you filled the form? Have you filled the form? I would like to share uh, uh, the prize with you also, Rahul. So will you please share it in the comment section? Your last two digit if you have already filled the form, Rahul. So let me check out. So Rahul, will you please reply? I think let me check out the form. Let me stop the screen so that I can only see the form, and let me check out if the Rahul entry is there or not in the form. Just give me a minute. I'm going to the form. Okay, yes, here is one entry. Okay, so 7-4. Okay, at the end the 7-4 is there. Rahul, 7-4 is there in your number. Okay, let me check out. That will come over here also. So Rahul, please confirm me. Otherwise, this will not be possible. Our first winner is Karthik and second winner is Rahul. Okay. So let me first our transfer the amount our to first winner, who is the obvious winner for every quiz. He comes here to win actually. Okay, just a minute. But I want to share the reward with Rahul also. He has done good actually. So I have transferred Karthik to you. Please confirm at your end. Please confirm at your end. Have you received your reward or not? Please confirm in the chat section. I have transferred from my side. And okay, let me see if this is the Rahul number or not. I'm taking from the form. So okay, I'm transferring amount to Rahul also. Okay, Karthik, you received great. So let me transfer to Rahul also. Done. this is actually transferred to someone else. Okay, fine. Then I have done from my side. Okay, let's go through the questions now. Let's discuss the questions which we attempted inside the quiz. So let me share my screen back. Let me share my screen back. Entire screen share, and let's go through the questions now. So let's go through these questions. Okay, so this is the first question. Okay, and let's see all these questions, and let me take the pen, open board pen, so that I can write on the screen. Let me take the open board. Let me go to the questions. Okay, this is the first question. Let's see the question one by one. Which of the following expression correctly check if the number is in the power of 2 or not? Okay, so the answer is this. Actually, we have already discussed this thing in the question also. So we solved two questions today based upon this concept. This concept simply says that if a number is in the power of 2, then if a number is in the power of 2, and if we take the end of that number with n minus 1, then we will get 0. Okay, we will get 0. So we use this concept to solve two problem today. One is to find if a number is in the power of 2 or the number is in the power of 4. So we solve these two concepts by using this statement itself. So A is the right answer over here. A is the right answer over here. Let me erase this thing. A is the right answer. Now let's move to the another question. So not operator is actually used for which purpose? This actually not actually invert the bits. This invert the bits 0 to 1, 1 to 0. Okay, not operator in bitwise operations invert the bits. So A is the right answer over here for this question. Let me erase this also now and move on. And next question is, okay, if we perform the one right shift over here, okay, one right shift, then one bit, then actually this will divide the number by 2. This will divide the number by 2. For example, if we have 10, 1, 0, 1, 0, and we shift by one bit, so this bit will go out actually. Okay, and remove this bit thus, and what we will be left with 101. So this is actually 10 in binary, and this is 5 in binary. So we can see over here that we are just dividing this number by 2. So we are getting 5. Yes. So whenever we shift one bit, uh, then this will divide the number by 2 actually. Okay. So A is the right answer over here. These are the basic questions, but important question from the bitwise manipulation. Which of the following is true for any integer n where n is even? Where n is even. So when n is even, actually, then the LSB bit will be 0. So for example, any even number I can pick. For example, 4. So in binary, 4 will be 100. Any even number, 6. 6 will be 4 plus 2, 6. This is 6. You can see that this LSB bit will always be 0 if a number is even. Any number we can pick. What about 8? 1000. This is 8 in binary. So LSB bit will always be 0. And when you will perform and uh, With even number, if you will perform AND with 1, then actually this will be 0 only. This will be, all bit will become 0. Okay, so 0 1 will be 0, and uh, here all bits are 0, so this will make these bits also 0. So whatever number we will pick, any even number if we are picking, its LSB bit will be 0. Okay, and whatever is the other bit doesn't matter at all, because we are multiplying, we are making AND of that bit with 0. So ultimately we will get 0. So if simple, we can say that if we are having a number n and we are performing AND with 1, then we will get 0 as output. Okay, if a number is even, if a number is odd, then we will get 1. In place of 0, we will get 1 if we are performing AND with 1. If a number is n is odd. Okay, so if you know this thing, this is very trivial, very basic. And if you don't know, now you can take this point that, okay, uh, this is how we can find out if a number is even or odd also by AND operation. Fine, okay. So let's move to the next question. Next question is, okay, what if we perform the XOR operation between 5 and 3? So this is 5 and perform XOR between 3. So here actually, if the number bits will be different, then output will be 1. If bit will be same, the output will be 0. Okay. So what we are getting over here in XOR, if the bits are same, then output will be 0. If bits are different, then output will be 1. So here bits are different at these two places. So this will be 110. So this will be the right answer. C will be the right answer. If you know how XOR work, you can answer this question very easily. Okay, fine. Let's move to the next question. Next question is, we can perform swapping of two numbers without using any extra variable using actually XOR operation. So by this XOR operation, we are swapping the two numbers A and B. Okay, so this is the actually most optimal approach to swap two numbers without using extra temporary variable. So without using temporary variable, by using XOR operator, we can swap the numbers. People can check out this thing by taking an example. You can verify this thing. So this is the most optimal way to swap the numbers. Okay, fine. Okay, so let's check out the next question. Next question is, okay, if we are performing OR operation, let's see OR operation between 7. This is 7 in binary, and how we write 2? This is 2 in binary. If we are performing OR operation, in OR operation actually, uh, if one bit is 1, then output is 1. So this is 1, this is 1, this is 1. So 7 we will get actually. So C is the right answer. Yes. Very easy one. Next is, okay. So this is about our DSA and system design course, and all options are right over here. In DSA and system design course, we are covering from basic to advanced. We have doubt support. We provide practice questions, and this complete practical oriented course. Okay, each and every session will be very helpful for you in this course. So if you want to check out this course, you can go to, okay, let me show you the course also. You can go to the, let me erase this thing first. What you can do, you can go to the iNeuron website, iNeuron.ai, and in the courses we can go to the boot camp. In boot camp we can go to the DSA. In DSA, here is the course I'm talking about, DSA and system design. So this is the most practical and most useful course if you want to go to the product based company, because if you really want to go to the product based company, then these two things will definitely will ask. One is DSA, one is system design, and this course is covering each and everything in very detail from basic to advanced. You can check out the detail of this course over here, and this is my guarantee that, okay, uh, I'm covering each and everything in very detail. I have 12 years of experience to train the student. The content which actually I have, let me tell you, the content which I have with me, that is refined over the time, okay, and that is to the point based for the product based company only. So this whatever I'm teaching over here, each and every session will be very helpful for you for DSA as well as system design, because this complete whatever I will be covering in the classes, that will be to the point based for the product based company only. I have removed the unnecessary information I have removed from my lectures, and I have put all those important concepts which are required actually. That's it. And we are covering every type of problem I have taken, different type of problem I have taken in my lectures. Okay, so over these 12 years I have built up this course, and just I'm providing this course to you people. And one guarantee I can give in this course is that every session you will find out useful. Single session, every session, all these sessions, single session, if you will attempt even a single session, you will find that okay, really you learned something today, because this is these sessions are refined over the 12 years. And I'm just providing now these content with to you people. Okay, so you can check out this course, and I can make you sure that this course will be definitely will help you to land in product based company. 101% will help you. Okay, fine. Okay, let's go to our questions back. So in this, all the or four options are right. Now let's move on. Next question is okay. Which of the following bitwise operator will set the kth bit of a number n to 1? So the answer B is right over here. So the simple idea here is that I have taken 1 and I have shift. So this is 1 in binary, 00001. Let's suppose I want to change the kth bit. Kth means third bit. Then I will shift 3 bits to the left hand side. Okay, so this will be 0, this will be out, this will be out, this will be out. Okay, so this will be 0 1, 3 more bits will be added over here, this place. And now this bit we are performing and or operation with our number. And whatever is the value over here in this number, either 0 or 1, but this bit will be set to 1 only. Okay, so to set the kth bit, we can use this statement. Okay, we can use this statement. So B is the right answer over here for this. And what about this? This is the similar question, but here if we are taking k bits right shift, then this will be divide the number by 2 power k. This will divide the number by 2 power k. Okay, if you are shifting 1 bit, this will divide the number by 2 power 1. If your k value is 2, 2 power 2, k value 3, 2 power 3. So whatever will, how many bits you are shifting, that with that number you are dividing the n number actually. Okay, so okay, fine, you can check out this thing. So B is the right answer over here. Here if you are negating a 0, so if your number is negative, then the MSB bit will be set to 1. If the number is negative, then MSB will be set to 1. Okay, so in this case this cannot be the answer because MSB bit is not set to 1. This cannot be the answer because MSB bit should be set to 1. So answer either can be this or this, but you are taking the negative of 0. So because you are taking the negate of that, so actually you are shifting all the zeros to 1. So all bits will be converted to 1. All 0 bits will be converted to 1. This one is showing that okay, this number is negative. This number is negative. So D is the right answer over here. Okay, that's it. These are the questions which I shared with you. These are the basic questions, but important questions from the bit manipulation. You people can note and you can practice this. So today we will cover the, okay, I'm going back to my screen, doing it, stopping the it. So today we will cover two product-based company problem in this session, and we cover the basic questions from the bit manipulation. So we are covering both. In every session we are doing this thing only. We are covering the product-based company problem, and we are covering the basic questions from one particular topic in DSA. I hope you find this session helpful. So if you find it helpful, give a thumbs up, and we will meet back on Wednesday with the next topic, with the next interesting problem. Bye bye. Take care for this session.